Hello everyone, these are the model answers for the Hooke's Law foundation question. A student investigated how the extension of a spring depends on the force applied to the spring. The diagram shows the spring before and after a force has been applied. Complete the following sentence using letters A, B, C and D from the diagram. The extension of the spring is the distance between the positions labelled, and it's B and C on the diagram. What form of energy is stored in the stretched spring? It's elastic potential energy. Then we've got a graph of some results. So the results from the investigation are plotted on the following graph. We've got force and we've got extension. The graph shows that the student has made an error throughout the investigation. What error has the student made? Okay, so for this one, what they've done is in this investigation, if you have a look at the graph here, you've got a graph that starts with 0 force and the spring has already got an extension, which can't happen because with 0 force, there's nothing stretching or pulling the spring. So extension, he has measured the spring length and not the extension. So he's measured it first with no force on, the spring's length before it's been stretched, which he shouldn't have done because the extension should be 0 when the force is 0, and that's the reason. Extension should be 0 when the force applied is 0. The student has loaded the string beyond the limit of proportionality. Mark on the graph line the limit of proportionality of the spring, label the point P, give the reason for choosing point P. Okay, so a limit of proportionality when you're doing Hooke's Law, we can tell this on the graph because it's the point at which the line stops being straight. So if you have a look at your graph and put your ruler on, we can see it stops becoming straight here at this point. If I draw a line down from that point, using your ruler, it's at 5.5 newtons. Okay, so I'm going to put my mark here, P. That's the limit of proportionality because after that point it starts being curved. If you have got a nice straight line like that, that means it's directly proportional. So the limit of proportionality means when it stops being directly proportional. So we're going to say up until that point, force and extension are directly proportional. Okay. So next part of the question. The student uses a different spring as a spring balance. When the student hangs a stone from the spring, its extension is 72 millimeters. The spring does not go past the limit of proportionality, which means that we can use Hooke's Law equation. Calculate the force exerted on the stone and the spring. The spring constant is 25 newtons per meter. Right, so the Hooke's Law equation is force equals spring constant, which is K, times by our extension, I'm going to show it as little e, sometimes it can be x. Okay, so there's a couple of things that we need to do before we put the numbers in here. You can see that the extension is given in millimetres, it needs to be in metres. Now, to get from millimetres to metres, we divide by 1000. So that actually will give me 0.072. So that's my extension in metres, so then I can put my numbers in. So force equals my spring constant, which is 25, times by 0.072. The answer is 1.8 newtons. Now that question is worth 2 marks, but say if you forgot to convert that and you just did 25 times 72, you get an answer of 1,800, you would get 1 mark for that. So it's really important that we get these conversions right, because we don't want to be losing marks because they all add up at the end. Okay, thank you for having a go at that, guys. If you've got any problems, please email me and I'll get back to you with the answers. Thank you.